In this lesson, we're going to talk about the different characteristics of quadratics. So in the previous unit, we talked about how to factor quadratics. So you know a quadratic is anything, any type of function where the highest degree exponent is 2, which would mean x squared. And when we graph a quadratic, it looks like a what we call a parabola. So this is a parabola. It's U-shaped. It can face up. It could face down. And actually, it could also face side to side, but we're not going to talk about those in this unit. All right, so the first characteristic we're going to talk about is the vertex. Okay, so on the front, I'm just going to kind of highlight here. So the vertex is basically the minimum or the maximum of the quadratic. So you can also say the turning point. All right, so let's write down the definition here. So the vertex is the absolute minimum or maximum of a parabola. Okay, the way we write the vertex, since it is a point, we write it as an ordered pair. So it's written as an ordered pair. Oops, not hair, pair. So it's something, comma, something. And the letters we use for a parabola is actually H and K, which we'll get more into later. But it's the x-coordinate first and the y-coordinate. Okay, so in looking at our example here, the vertex, which I'm going to highlight in red or pink, is right there. And the coordinates of that point, remember we do the x first, so it's 3, -4. So the vertex is 3, -4. All right, the next characteristic is called the axis of symmetry. And the axis of symmetry, which I abbreviate as AOS just because it's a little bit easier to write or to say and to write, is basically the vertical line that cuts the parabola in half. And you usually draw it as a dotted line. Okay, so it's the vertical line that cuts the parabola in half. So writing down the definition here, the vertical line that cuts the parabola in half. Okay, and for the axis of symmetry, since it's a line, particularly a vertical line, it's always written as x equals something. Okay, and this is always whatever the x coordinate of the vertex is. Okay, because the axis of symmetry always goes through the vertex. So in looking here, here's our vertex. So the axis of symmetry is the vertical line that goes through that point. So drawing it in as a dotted line, it's going to be x equals 3. So you can look at just the vertex, and whatever the x coordinate is the same number you would write here. Or you can actually look at your graph and see, well, this vertical line crosses the x-axis at 3, so it's x equals 3. All right. The next term is called the y-intercept, and this is something that you have heard of. The y-intercept is the point where the parabola crosses the y-axis. And this will always be written as an ordered pair. And the x-coordinate is always 0. So it's always going to be 0, comma, and then wherever it crosses the y-axis would go here. So it's always written as a point, 0, comma, and wherever it crosses. Okay, so looking at our example here. So here's our parabola. Okay, and the point where it crosses the y-axis is right here. So the y-intercept is that point right there, and it crosses at 5. So the y-intercept is going to be written as 0, 5. All right, the next term is x-intercepts, and we can also call those zeros. So this is where the parabola crosses the x-axis. Okay, maybe something I'll point out now, which will come up a little bit later, but a parabola does not have to have x-intercepts. There is a possibility that the parabola can go like this, and in that case, there would be no x-intercepts or zeros. Same thing, it could be face down this way, and it will never cross the x-axis. So there doesn't always have to be 2. There may be 2, there may be 1, and there may be 0. All right, so our definition here, x-intercepts and zeros, is the points. And I'm going to put the S in parentheses because, like I said, there could be 2, 1, or 0, where the parabola crosses the x-axis. Okay, and these ones are written similarly to y-intercept, except the 0 switches places. So it's going to be blank, comma, 0. So the reason why x-intercepts are called zeros is because wherever they intersect the x-axis, the y is always a 0. That's why it's called a 0. All right, so looking at our example here, there's our x-intercepts. So the first one is going to be 1, 0. That's this one right here. And the second one is 5, 0. And you do need to write it as a point because the x-intercept and y-intercept are both points. So you need to write them as points, ordered pairs. Okay, the next one is domain. So domain is basically what possible x values you have. And the other one is range. Hold on, let me find a color to use. Okay, and range is all the possible y values. So in looking at this parabola, this one's a little bit hard to understand. So looking at this parabola, okay, it gets wider and wider and wider. So if we're thinking we're going to draw these vertical lines that crosses through the parabola, we can keep drawing vertical lines forever and ever and ever, left and right, and eventually that line will cross the parabola. For the range, we're just looking at the possible y values. Well, the lowest this parabola goes is right here. So my range starts at -3 and it continues on forever up. Okay, so this is one that we're going to practice a bunch of times, but for now we just kind of need to get the gist of it. So the domain are all possible x values. And to find the domain, we always look left and right. So what's nice about the domain for parabolas is it's usually -infinity to +infinity. So we write this is called interval notation. We write the lower bound and then the upper bound. So meaning it continues on forever left and it continues on forever right. So it's usually that just for quadratics. You can also say this as all real numbers. Okay, so for range, it's all possible y values. So for this one, we look down and up to find that. So this is always is going to be written like this or like this. So this is interval notation. This number is going to be the y value of the vertex. Okay, it's written like this one if your parabola faces up, meaning it looks like this, and it's going to be written like this if your parabola faces down. Okay, so meaning we start at the very bottom part and it continues on forever up, meaning going on to infinity. For this one, it goes forever down, but the highest point it reaches is the y value of the vertex, which would be right here. Okay, so let's look at our example. So looking at this parabola, the domain is going to be all real numbers. Okay, this is going to get wider and wider and wider, which means it goes on forever in left and right. So my domain is going to be negative infinity to positive infinity. And my range, the lowest point of my parabola is starting at 4. And it continues on forever up. Sorry, at negative 4. So my range starts at negative 4 and goes all the way to infinity. So the reason why we use the bracket on the range is because the parabola actually starts at negative 4, so it includes negative 4. We use the bracket when it include it. The reason we always use parentheses with infinity symbols is because infinity is not a number, so you can't really include the number infinity in your domain or your range. I should also say here that domain can also be written in words as all real numbers. And remember, that is the case for quadratics. If you're just looking at a graph of a quadratic, the domain will always be all real numbers. All right, let's look at the last term, which is interval of increase and interval of decrease. So interval of increase, which I'm going to highlight in kind of more of a lime green here, interval of increase is the x values for where the parabola is going up. Okay, so if we think of this as a roller coaster and we're riding the roller coaster, we go down, 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 and then starting at the vertex, we go up. So the interval of increase starts at -2 and continues on to infinity. So this is the side of parabola where we're increasing. For interval of decrease, which I'm going to highlight in a, let's do a light blue. Interval of decrease is the part of the parabola where it's decreasing. So if we're thinking of riding a roller coaster, this is the decreasing side because we're going down, down, down. So the interval of decrease would go from negative infinity to -2. Okay, so in terms of definitions here, interval of increase is the x values when the parabola is going up, and this is going to be written using interval notation. Where you list the lower bound and then the upper bound. And then interval of decrease is the x values for when the parabola is going down. And we use interval notation for this one as well. Sorry, that's kind of hard to see. All right, so let's look at our example here. So here's what you can think about. The axis of symmetry, which is right here, cuts your parabola in half. On one half of the side, the parabola is going up, and the other half, it's going down. So for this parabola, the half where it is increasing is the right-hand side. Because if we're thinking of riding a roller coaster, we start on the left-hand side, we go down and then up. So the increasing side goes from 3 all the way to infinity. So my interval of increase is going to be 3 to infinity. The interval of decrease, well, it's decreasing on the left-hand side, which means it starts at negative infinity and decreases all the way until we get to the axis of symmetry, which is 3. So the number that you write in your interval of increase and decrease is going to be the same. You just need to figure out which side is increasing and which side is decreasing. The right side is increasing, so it starts from the axis of symmetry to infinity, and the left side is decreasing, which means it goes from negative infinity to 3. Okay, now I'm going to go over a couple of the practice problems. So first, looking at this one, these are the characteristics we're identifying. So first of all, the vertex is, remember, the minimum or the maximum, which is right here. And the coordinates for that is 1, -1. The axis of symmetry is the vertical line that cuts the parabola in half. So we actually don't even need to draw it on there, because if you know your vertex is 1, 1, that means your axis of symmetry is just x equals 1. Remember, the axis of symmetry is the same as the x-coordinate of the vertex. The y-intercept is where it crosses the y-axis, and it's right there, and that is the origin, so that's 0, 0. Then for the zeros are where it crosses the x-axis, also the x-intercept. So the y-intercept is also an x-intercept, so it's 0, 0. And then this is the other point, which is 2, 0. The domain for any parabola, remember, is all real numbers, or you can say negative infinity to positive infinity. And then for the range, we ask ourselves, how low does the parabola go? So the lowest point is -1, or you can look at the y-coordinate of the vertex. So the range goes from -1, and then it continues on forever upward. So it's -1 to infinity. All right, I'm also going to do this one. So this is a parabola that faces down. So the vertex is this point right here, and the coordinates of that is 1, 4. The axis of symmetry is just going to be x equals 1. For the zeros, we are going to have to estimate. So to me, that looks like -1/2, so -0.50. And the other one looks about 2.5, so 2.5, 0. Okay, my y-intercept, it crosses my y-axis right there, so y-intercept is 0, 2. Domain, automatically we know it's negative infinity to positive infinity. And then for range, first thing we ask ourselves, how low does it go? Well, since it's pointing down, that means it goes forever down, which means negative infinity. And then the highest it goes is just the y value of the range, which is 4, so negative infinity to 4.